So the title's up there. We're doing Chapter 2, Section 6, Solving Addition and Subtraction Equations. And for this, while you copy that down, just want to make a comment. Maybe you've done this before. Maybe this is the very first start. It's going to be something that you get a lot of practice in over the next few years. This is kind of like key to being able to do a lot of like upper math, like algebra and stuff. And I'm going to be looking for you to show your work, even when you can look at the problems, just be like, well, I know the answer is 4. I want to see your steps. And here's why. I used to teach Algebra 2 for a bunch of years. I had a student in class that was doing really bad in the class, like barely passing. I was helping him after school one day and found that I was kind of thinking, this guy's just not very good at math. Turns out he could do math in his head, and I was having trouble keeping up with him, which is uncommon. I was like, seriously? It's like, so why are you doing so terrible in my class if you're like crazy off the charts good at math? And what it turns out, when he was sitting in your shoes here, the teachers are teaching, okay, here's the process for solving an equation. And he could just look at it and be like, well, the answer is this. And then you get to like the next step harder. And it's like, well, no, this is what you do to solve ones like this. But he still could look at it and do it in his head. The problem is he got to a point once he hit Algebra 2 where he couldn't do it in his head anymore. He hadn't learned the steps back in like 7th, 8th grade, and then he was just sunk. And I think that you'll find that that's true for you. Maybe it'll be later on this year, maybe it'll be next year, maybe it'll be all the way till you get to Algebra 2. But if you don't learn the steps, you're going to pay for it down the road. Fair enough? So that's why I'm asking you to show your work. And it's really, when you get the steps, it's really not bad. It's not bad at all. Okay, so first thing I want to start out with is just kind of the definition of an equation. But I think this is something that you all can do. I hate to start with a story like that and maybe freak people out. But if you have an equation is really just something equals something. So something equals something. And how often I've described it is you just need to have an equal sign and something on both sides of the equal sign. So if you wanted to throw down some examples, you could do something like x equals, anyone, a number? 2. X equals 2 is an equation. You have an equal sign, you have something on both sides. You could instead, if you wanted to, do like x plus 5 equals 9. Or throw in a whole bunch of letters. 3xy plus z equals pi. Pi plus 17 minus w. Just need to have an equal sign and something on both sides. Good? Good. A lot of times books will refer to like equations, kind of like if you can picture in science class like the old pan balances, something that you have like a pan on one side. I wouldn't draw this, but pan on one side, there's like a little arm, and then it goes down into something like this. And what you would do is if you put something on the left, and the left side is heavier, then the left side's going to go down, right? If you put something on the right that weighs the exact same amount, then it's going to come back up and the two are going to be balanced. So a pan balance, based on how it tips, you can determine, is one side heavier than the other? Are both sides equals? Good? In an equation, they're always going to be equal. So we know that it's like one of these balances. Both sides are the same. So in this one up above, we know that x plus 5 has the same value as the other side. We know they're equal. We know they're balanced. So if we want to do something to one side and make one side, say, lighter, to make it balanced again, then you have to make the other side lighter as well. Can you kind of picture it? Okay, so that's kind of the analogy. That's kind of where we're going. So if we're solving an equation, because the title says solving addition, subtraction equations, by solving an equation with a variable, basically it means we're trying to figure out what that variable equals. So I'm going to say, put a little star, solving an equation. I'm just going to do EQN for equation. So solving an equation. So when we're looking at solving an equation, basically it means we're finding what the variable equals. So finding what the variable equals. So your answer will always be something like x equals 7 or y equals 4.2, or something like that. Your variable equals something. And to do that, you do the inverse to both sides. So do the inverse to both sides. And I'm going to add a little bit to that in a moment. But we talked about inverse a couple sections ago. And we said the inverse of adding 4 was to subtract 4. That the inverse gets you back to where you started. Or the inverse of walking 4 steps forward was to walk 4 steps backwards. Or you could do east and west or up and down. Walking down a flight of stairs, the inverse would be to walk back up the flight of stairs. Okay, so you do the inverse to both sides, but for that inverse, you do the inverse of what was done to the variable. So do the inverse of what was done to the variable. And okay, so my first example is going to be kind of weird, but I'm going to say it's not really an example maybe even, but I'm going to say I start out with a x equals 7. Does that work for you? If I were to add 2 to the left side, to keep it equal, I have to add 2 to the right side. Yeah. But on the left side, I don't just have x. On the left side, I now have a x plus 2. And on the right side, I have 7 plus 2, but 7 plus 2 is just 9. But does that make sense? We started out being equal. Now we're still equal because we did that same thing to both sides. Now the reason I did that is most of the problems that we do from here on out are going to start right here. So they're going to give you an x plus 2 equals 9, and they're going to say, all right, we need to find out what x equals. We're trying to get this thing here, the x equals 7. To do that, what I was trying to get up here with my point is you do the inverse of what was done to the variable to both sides. That if we want to get back to figuring out what x is, well, in looking at this line here, they took x and added 2, right? So the inverse of adding 2 is to subtract 2. So to solve one like that, we would just go through and say, all right, I'm going to subtract 2 from both sides. Because I did it to both sides, it's still equal. And subtracting 2, that just cancels out my adding 2. Those are inverses, so they undo each other. And I end up with x equals 7. So we'll kind of start at that halfway point and then just work back to where they began. Example, x minus, and I'm jumping from like a nice pretty one to like something that's like really twisted and wrong, equals negative 244. And I tried picking, and I got the holy cow, I tried picking something that the answer's not obvious. Looking at that, I couldn't tell you the answer off the top of my head. But what step do we do to figure out what x has to be? Go for it, Kai.
Add 322.
Perfect. So we say, well, what was done to x? Well, they had x, but they subtracted 372 from it. So we need to do the inverse of what they did. We need to add 372. And when we do that, my left side, the 372's cancel out because they're inverses, and we're just left with an x. So now we just need to do negative 244 plus 372, which ends up being 56 plus that, 128. You can see where a lot of you would probably just use your calculator for one like that. And I'm okay for using calculators for nasty, ugly things. But if you get nice numbers, 9 minus 2 and a lot of those, do it in your head. It'll save you time. It's good practice. So do it in your head, then check it with your calculator if you need to. An example that's going to be a little bit more normal, a little bit more loving maybe, is if I were to say, let's do x plus 17 equals 21. I'm going to ask you in your homework to write out the original equation. So if the book gives you something like this, write down x plus 17 equals 21. Now what do we do to both sides? Yep, so subtract 17 from both sides. So I'm going to look for you to write down that, like the 2 minus 17s. And then left side, those cancel out, so they're inverses. We're left with x equals 21 minus 17 is 4. So in your homework, I'm looking for you to set them up kind of like that to show your steps. And showing your work makes it easier. It's for your own good. It makes it easier. That's it.